Um, let's start in on the R's. There's about 13 functions that start with the letter R. And the first one, range function. I really think there should be a built-in range function in JavaScript in any programming language. Making one is kind of a pain. Like, there's cool ways to do it, like with recursion, but JavaScript will give you a Stack Overflow very quickly, depending on how large the number is. It's not performant. Um, and the other ones just feel like they involve too much. So I'm glad there's a range function in Ramda. It's quite simple. It takes two numbers and returns a list of numbers, which will be your range. What it said returns a list of numbers from inclusive to exclusive. So this is the only tricky thing is that if you want a range of one, two, three, four, you have to tell it to go from one and then stop before five. I don't know why we can't have nice things. The one thing that I'm not too fond of is that there's no step um, parameter or argument. Like it just assumes that it's going to increment an integer. And if that's the case, can these really be numbers or do they have to be integers? Let's find out. If you can't tell, I've spent too much time making range functions in the past, just trying to find something that was like as simple an implementation as what you get as the result. I just want some numbers. Um, so if I did 1.1, yeah, that doesn't work. But what if I did 1.1 to 5.5? Or would I need to do 5.1? Yeah, I think that would make sense. Yeah, that doesn't work either. So I do want to look to see how they implemented it. I mean, if you implement it imperatively, it's not too hard, but it's saying if it's not a number, it's checking these two arguments, and if they're not numbers, there's an error. Um, and then it makes sure that the from is below the two, otherwise it changes, it has a default of zero or something. Sets an index, loops through it, increments by one. I don't see anything here that tells me that it has to be an integer. And you can increment a decimal, but it doesn't work for some reason. Let's look at the error. Valid array length. Oh, it's telling me how many items I need to go to, not like a range would be like 1.1, 2.1, 3.1. Like it's always going to put an integer in there. It's always going to, yeah, that's what the range function does. Derp. Um, anyway, I'm glad I explored that just a little bit, but I don't think there's anything else to say about that. Uh, let's move down to the rebuild. So that's an interesting name and type signature. Uh, let's see. So it takes function that takes a pair and returns a list of pairs. So like a nested one. So it takes a string and an A, and it returns a list of pairs that are strings in B and an object. So the key, probably what the string is, and the A is this A. Yeah, I don't even know what this is doing. It returns an object with the key and a B. So let's see. Okay, so this first function is called a convert function. It's a function that converts a key and a value to an array of key value arrays. So like pairs, right? Like an array of pairs, key value arrays. And then the object, structure to convert, and it returns an array. This is showing object though, but an array, a new object whose key value pairs are the result of applying the convert function to every key value pair in object. Okay, so I'm gonna oh, I see what it's doing. The code is just simpler than English, I think. It also depends on the use of the English. So that is taking, here's the second argument. Okay, so the first one is a function. It's a it's the convert function, and it's taking a pair, which is a key value, and here's a key value in the object, or several key values. I'm just wondering why it shows that it's an array here, but here we're just getting the key and the value, so we'll figure that out in a minute. And then we're returning a key value pair inside an array. So what we're doing though, and this is pretty cool, we're taking this key and we're applying this function to it, and we're taking the value and applying this function to it. This is actually just an expression, not a function. Well, yeah, well, both of these are expressions, even though this is using a method technically, but the whole thing's a function. All right, so there's their function or data. So let's run it real quick. Save. Uh, what's going on here? I need to log it. I forget that all the time. Somehow I put characters in there that don't belong. Finally. Okay, so what we're doing though is we're taking this A1, B2, C3 lowercase keys. We take the key and we uppercase it, and then we take the number and we square it. So we get 1, 4, 9, and then we return an object. And that bugs me because here it's saying it returns an array. Uh, but it returns an object as specified up here, and it's just transformed both the key and the value. I really wonder if this belongs in the list. I don't see at any point where a list comes into play here. But I mean, it is creating, it's creating a function here, and I wonder why that's nested, because it's doing this multiple times. That's why. So we're going to have multiple results, but at some point it converts it back to an object. And that's just, and I mean, that's obvious here in the signature, but not obvious in the explanation here. So there's either a reason they did that or it's just an oversight. But let's read the definition now, since we've seen what it does. Transforms an object into a new one, applying to every key value pair a function creating 0, 1, or many new key value pairs, and combining the results into a single object. Well, if I just read that to begin with, it would tell me what's going on. I really think it's just the I think this is just a typo right there, returns an array. Yeah, so that's cool. So what else could we do with it? I mean, we can do anything. We just transform the key and transform the value. We could not do that and do r dot identity and just square the values, but is that going to work because of this key? I don't think it will. Let's see. Yeah, it doesn't work like that. We'd have to say r dot identity of the key. That would work. It would just square the other ones, but that would also be like what, map keys or not map keys, but no, it would just be map because you can map over an object, but the transformation function applies to the value when you do that. Um, yeah, so whatever you want to do, you could do to it. We could we could concat a taco to it. I think we'd have to specify both. Yeah. Yeah, actually pretty useful if you need to massage data. Again, my the first thing I think about is just massaging the data you get back from a REST API call. I think that would be the obvious thing. Um, yeah, yeah. So that's rebuild. And again, I don't think it should be list. I think it should be object. Let me know in the comments if I'm missing something. And then so we get to reduce, right? Map filter reduce. These are the basis of functional programming. I'm not going to demonstrate how reduce works because you're watching this, you know how reduce works. But I am going to read through it because there are some differences with reduce compared to the reduce method that's built in on arrays. So it returns a single item by iterating through the list, successively calling the iterator function and passing it an accumulator value and the current value from the array, and then passing the result to the next call. So I've always called, instead of iterator function, I've always called it the reducer function. The iterator function receives two values, the accumulator and the value, just like regular JavaScript. And it may use the r.reduced to short circuit the iteration. So that's one thing, but that's a separate function that we'll get to in a minute. Um, the argument's order of reduce right, which this is just reduce, um, for the iterator function is value and then accumulator. So that is different, I think, than reduce right, that is a array method that's built in. And so they state that here s- specifically just in case you are used to using reduce right, like making your own compose function or something. Uh, so even though it doesn't apply to this function, they just want to say, by the way, if you do use reduce right, it's going to be the opposite. So you can't like use the same reducer function or what they call iterator function. The other thing that's different here is that reduce does not skip deleted or unassigned indices, which also called sparse arrays, unlike the native array reduce method. And then you can read more. This I don't really understand an example of, but it says be cautious of mutating and returning the accumulator. If you reuse it across invocations, it will continue to accumulate under the same value. So the general recommendation is always return a new value or be sure to reinitialize the accumulator each time you invoke it. Um, I'm sure there's some gotcha somewhere, but I've never run into it, and they don't give me an example. So, yeah. And then it gets into this dispatches to blah blah blah, which we're not going to get into in this series of videos I'm doing. Um, and then an example of reducing. So we don't need to see how reduce works. But the one thing you do have to do, you have to pass it the initial value of the accumulator. That's the second argument. And in JavaScript, you don't have to do that. It will automatically use the first item in the array that you pass it. Um, so if you're going to do like make your own sum function, you don't have to pass a zero if you're using the array.prototype.reduce, but here you have to pass in an argument. Um, Otherwise, it just thinks that the array that you're going to pass to it is the second argument and it's only partially applied, and you'll get an error message, and that's why. Um, so that's reduce, but I do want to go ahead and look at reduced, and then we'll get back to reduce by. Um, Reduce is kind of a special function here called a list function. It takes A and returns anything, right? And then this tells you even less. Uh, well, actually, X is the final value of the reduced. And yeah, it says it returns the wrapped value. So it returns a value wrapped to indicate that it is the final value of the reduce and transduce functions. So we're not worried about transduce right now. The return value should be considered a black box. The internal structure is not guaranteed to be stable. I'm not really sure what they mean by that, except that maybe there's like an error inside. Um, well, we'll get back to it. But you can use this function with these functions: the reduce while, by, write, and transduce. And what it basically does is it allows you to short circuit reduce, because sometimes you don't need to go through the entire array to find the value, or to calculate the value that you want to return. Um, it can be very expensive if like you get to the second item in the list and you that's the result you want, and then you continue iterating. Um, that's a big, or it could be a big performance hit. So what we're doing here is this is our reducer function. Let's put this on. I think it's easier to read ternaries when you do it like this. I'm going to run the code. Always forget to log. It's a little messy, but anyway. So you get one, two, three here. So what we're doing is we have this guard to check if the item that we're passing in is greater than three. And if we are, we just want to wrap the value in a reduced and then just return that. Instead, if not though, if it's equal or less than three, we're going to run this branch and just add the next item. We're starting with the empty array, so we're just making a new array, essentially. I mean, this is a contrived example. You wouldn't really do this, but it shows you what the reduce does. The reduce basically just stops the execution once you've found the value that you want. Once you've the accumulator has become the final result, and the rest of the thing you're just returning the accumulator anyway. So why just go through those extra steps? So that's reduced. So let's go back up to reduced by, or reduce by. And so this guy has just got an extra parameter. Let's start by looking at this and the signature together. So the first function here is called the value function. This is the function that reduces the elements of each group into a single value, receives two values, the accumulator and the current element, right? So this is your reducer function. This is the initial accumulator, same thing as reduce so far. But then we have this key function, and this is the function that maps the list elements into a key. So we're going to, if you see the output is going to be an object, and this string is going to be the key that is generated by this function here, the key function. And then just like reduce, you pass it a list, and this is the return value. So it returns an object with the output of key function for keys mapped to the output of the value function for elements which produce that key when passed to key function. Okay, so that's a little hard to understand, but when you see the example, it's not too difficult. Let's read this. The groups the elements of the list according to the result of calling the string returning function on each element and reduces the elements of each group to a single value via the reducer function. It's basically the same thing I just read. And the caveats is that the value function receives two values, the accumulator and the value. It can be reduced, can be used to short circuit the iteration. And it's basically just a general group by function. All right. So we're just like grouping by a key to organize our data. So let's look at this example. Okay. So this is our reducer function. It's taking the accumulator and it is, what do you call that? Destructuring the name property from the object that we pass in. You know, as we loop through these students, we'll pull out the value of the name property. And then we're just going to add that name onto the accumulator. And so that's our group names reducer function. This is our accumulator initial value. So we're just going to basically add stuff onto this array, much like a while loop. And this is our students, which is just an array of objects. But the to grade is the extra thing. The to grade is the by. And we've got this really nested ternary, and my prettier extension did that for us, but you can see how it works here. It's just going through in order from low to high, and if it's within a range, it's going to assign letter grade, A being the default. If it's anything over 90, um, so when we run it, um, do we get an error? Because they did not include the R dot in their example, and I did not log it. All right. And so we get this object back. So we're reducing, and the reduce is just basically taking the name out and it's concatenating it. So we get Abby, Kurt, Bart, and Dora, but we're throwing in this to grade function. We're not going to just get back a flat list like we would if we used reduce. Let's test that theory. Let's just go here and change this to reduce and take the to grade out of the picture. We should just get Abby, Kurt, Bert, Bart, and Dora. Uh, and we do. But with by, it lets us group, and that's what it's saying here. It's just like a fancy or a more general group by function. And now, just if you compare those two, I think it makes perfect sense. So we've got, anything that satisfies this to grade, we destructure the score property out of it. And if it's like, same, but yeah, Bart has less than 65. So it's doing two calculations at once. It's doing one that's like reducing it to create the accumulator, but then it's doing another function to decide how to break up that accumulator into an object and what keys to generate to break it up. So I may not have explained that great, but I at least understand it. Um, and that's something. And you can rewatch it and you can play around with it. And I don't want to go back to group by. This is getting a little long. This might be a good place to stop as well. We've already done reduced. Except for reduce right is the same thing as reduce, except for we're going from right to left. And we've already touched on the fact that the iterator function receives value and then accumulator, not accumulator value. So you're going to have to switch the arguments, um, or if it's point free, you just need to keep that in mind. And then we can use reduce to short circuit it, and it doesn't skip um, empty arrays like on a sparse array. It doesn't skip anything. And then that caution warning. So I think we can go ahead and I think we can go ahead and just check that off our list. And looking through these, there's several more in the R's, but it makes sense to just knock out the reduce while, huh? Because it's grouped with all these, and then we'll call it a video. Get rid of that. Okay. So again, we've got a predicate function this time. And then we've got our normal reducer, or what they call iterator function, taking accumulator and the value and returning the accumulator. This is the initial value of the accumulator. This is the list that we're iterating on, and this is the value it's going to return. The only thing we've got different here is this predicate. And notice the predicate is taking the same types of values, probably the exact same values, as the reducer function. So, I mean, I can already tell what this is doing just from that. It's going to do all this, but first it's going to check if the if this predicate condition returns true, and then it'll do it. And if not, it won't. And and I think what it's going to do is it's going to short circuit. It's not going to just check on each one. It's not like an if statement. The while, like a while loop. Let's read this first. Like reduce while returns a single item by iterating through the list, calling the iterator function. Can't pronounce this word for some reason. Successively, one after another is what that means. Reduce while also takes predicate that is evaluated before each step. If the predicate returns false, it short circuits. Yeah, it short circuits the iteration and returns. It returns the current value of the accumulator. So reduce while may alternatively be short circuited via reduced. So yeah, you can use reduced to short circuit it. But you could use this predicate function, and I kind of like that a little better. let's grab their example. Let's get the first one. Got a is odd, got some data, and we're going to log function call, get 9. So reduce while, I mean, it reads, reduce while is odd using r.add, start at 0, and here's the data. So 1, 3, and 5 are odd, but 60 is not. So we add 1 and 3 is 4, 4 and 5 is 9, and then we stop because it's checking this value, So it's like a guard built into reduce. You could also just use reduce and put a ternary or if statement inside your reducer function, but this is so much cleaner. Like you're separating the concerns of your function. Um, yeah, yeah, that's reduce while. Um, and let's look at the parameters. Yeah, predicate is past the accumulator and the current element, just like the function gets. It's like a doorman, or security guard or something, checks for clearance before the function runs. I'll probably start using this a lot, actually, because there's always something you should be checking. Not always, but a lot. That was pretty long. Um, we'll pick up with reject, which we've already looked at anyway, so we'll just briefly touch on it. And the rest of these are pretty straightforward, I think. We've looked at a lot of them, or some of them maybe. So we'll knock these out in the next video, and we'll be done with the R's. Thanks for spending your time with me. Tell a friend, and I'll see you in the next video.